Okay. I'll just add the LinkedIn streaming link here. So that would give you the recording also, and you can add comments if you want, interact with people there. Come back, watch the recording also. 1 second. Lots in the chat. Is that intro? So Zoom has this thing that you can continue the conversation. So what they've done is they have saved the conversation because we are using the same Zoom link each time and we're just continuing on. So they are keeping on the chat. So the last week's chat is going to just continue on right here. So okay, this is where I'm streaming on LinkedIn. Somebody check it for me if you don't mind that it is live. Okay.
I'll check it, Sudha.
Okay, thank you so much. Then maybe you can add a comment saying we are live. Okay. Okay, people, we are ready. Looks like. Okay. Yeah, I see it is live on YouTube also, so that means we are fine. Okay. Let me go back to Zoom so I can see my own face. And all of you here. Okay. Hi, Ritu. I see new people joining in. Okay. So, hello, everybody. I'm Sudha Jamthe, and this is Weekly VED from Business School of AI. So, you might be watching this as a live stream because I'm here on Zoom with a select set of people. So we're going to have an interactive webinar. This is part 2 of large language models, LLMs. I did one last week. Typically, Weekly VED is a speaker series. So I pop in and come and do a webinar periodically, or, we might invite somebody to do a webinar. We had one on prompt engineering sometime back from Robert Schwenker. And what else? So for those of you who are joining me here, because this is streaming onto YouTube and LinkedIn, if you do not want to be in the recording, because we will be sharing this recording and reusing it, because there is a lot of ask around that, even for last week, you can be off camera. You don't need to speak up. You still have the privilege of being able to ask me questions, and I will cater to make sure that I answer your questions. So you can chat your questions. So what we typically do is we chat an introduction just by our name and where we are joining from, because this is a very global audience. I see people staying up late at night joining me here. And I'm here in California, and it's 8 a.m. right, and early in the morning, and a very beautiful day, like one of our attendees said here. So any other logistics? I've added the LinkedIn chat link, right? I mean, the LinkedIn streaming link right here. So for those of you who are watching on LinkedIn, I'm monitoring that. I'm not monitoring YouTube. So you can add a question, tag a friend. You can come back and watch this and post questions. I typically like to go back and look for comments and questions and find you answers. That's my job here. And then for those of you here, I've added the link on the LinkedIn, as I said, so you don't have to, just chat here. You can chat there also. It's your call. Okay. And no pressure. We'll finish by 9 o'clock in another 50 minutes. And I'm happy to continue on to answer your questions, as I said earlier. Okay. So large language models is like the new craze, right? After ChatGPT, we had, this has become more like a buzz with generative AI, but they've been around for a while. So one of the things we did last week was the part 1 of the webinar, and we went into, under the hood, what are large language models, and we went under the hood, and we had Yashashwini Vishwanath, Yash, here, who gave us a surprise demo on her favorite topic of recommender systems. And she said, let me show you how to build a recommender system on top of ChatGPT. And so that is all there in last week's recording. And Yash was saying I should show you where to find last week's recording. Okay, so I'm just going to share my screen first to show that you guys, and then I will continue on with my session. Go into my YouTube. Okay, so you have two options. So this is my YouTube where we stream weekly WED every week. So it goes here. So today's thing is live. If I click, it will show me the live. And it also shows the Sudha live that I do, like about AI opportunities and stuff every Friday. So that will be under stream. We also have a playlist, I believe, that Paria has set up. So we have bit.ly. Let me see if I can find that. So this event is called Weekly WED, and Weekly WED registration is how you got into the Zoom Weekly WED playlist. Am I sharing my screen, guys? I'm sorry about that. Am I sharing? Yes, I am. Okay. So,
Yes, we can see.
yes, thank you. So, Weekly WED playlist is where the entire playlist of all weekly weds are archived. So if you can just follow my YouTube, you'll get the stream, or we have multiple newsletters, and we usually share all these links in there. And I have so much content, but specifically for this webinar, we will also be sharing the webinar links in my newsletter that goes out on Mondays. But the easiest thing is go to YouTube and you will see all the past weekly webs. When I say, oh, Robert Schwenker did a past webinar, you can come back and here is the webinar from Robert. So we've had a lot of discussions. Muskan came in and did a session on generative AI, building language models using open source, and a poster that she did in Europe. So we have a lot of this. So I don't want to go back to that, right? And my favorite person, Blessing, has done a beautiful session too. Okay, so I'm going to stop that. So bit.ly slash weekly wed playlist. Okay, so let me come back. Okay. Okay, thank you, Yash. And if somebody is able to find the link for the last session from LinkedIn, I'll appreciate if you add it to the chat, because that is where I'll continue the conversation. So if you go to YouTube, you can just watch the archive. It's like a online lesson at your own pace. Nobody's tracking you, nothing. But on LinkedIn, you'll be able to come back and see the sessions and continue on the conversation and the like. So that's the idea. That, and I believe if you join Business School of AI on LinkedIn, you should be able to get that stream also. So that's my understanding, because all weekly Wednesdays we stream on Business School of AI. So if you join Business School of AI on LinkedIn, you can get that. Otherwise, we will share the webinar link here. Okay. So I've answered your question. Now I'm going to ask you some questions since you attended last week's session. One of the things I promised was to share the deck. I apologize, I haven't done that. I just updated the deck with this week's webinar content. So I promise I'll put that together. You should get that in the newsletter. So let me add that. For those of you who are not on the newsletter, it is bit.ly/Jamthe newsletter. And I believe many of you who got a reminder for this session get the weekly web newsletter. So I'll make sure that in all the newsletters, I'll make sure that these two webinar links are included. That's my promise to you. And I'll put the PDF of the presentation and make sure that you get access to that also. Okay. Okay. So question for anybody who has been there before, or if you're willing to answer that. So I'm just going to ask a couple questions to just make sure that those of you who missed it, or you're kind of, new to this, heard it last time, but you want to make sure that we are on the same page. So quick question: is a large language model a neural network? Yes or no? And no question, no, if you don't know the answer, it doesn't matter, and there's no bad answers. Okay. um, The LLM is a large language model, and large language models are foundation models. And foundation models is the big thing in the world of generative AI. And essentially, it is a huge model that has been trained with the world or English data from the internet, essentially. And and then on top of that, we are building chatbots. We are doing other applications. We're going to talk about how we go to the building phase. What we covered in the first part of the webinar last week was how does it work under the hood. So I still want us to make sure that we understand that, because now what we are going to do today is we are going to learn fine tuning and prompt finding, and we are going to go past that to do something more, to build applications. And the most famous one that everybody knows about is ChatGPT. This particular Zoom that some of you are here on, we also have turned on the AI assistant. So at the end of this session, you should get a summary of our session, not the chats. They've said that Zoom said that we don't have, we won't track the chats and something, that's private. But officially everything that I'm saying, if if you speak and ask a question, everything that's a transcript of this session, it takes that and it does a summarization, so you'll get a email of that. And somebody please tell me whether you got an email last time, otherwise I will make sure that you do. Okay. Okay, so the question was, so large language model is a foundation model and it's been trained from the world. There are a bunch of language models that's available out there, PaLM, GPT, various GPTs. All of them are foundation or language models. Lambda, T5, there's a bunch of open source one from Hugging Face, Bloom Chat. All of them are foundation models and they're available to build upon, to build the next level application. Chat, intelligent chat, which is context aware chat being the most famous one. But we're going to talk a little bit more. But so one of the things I'll tell you is a large language model essentially is how it works in its brain is it creates a mental map of words and the relation to each other. So when I say it is trained using the world of language and English, it basically takes all the words and then it says, okay, how is this word related to every other word, and creates a mental map in its brain. And that is how when we chat with ChatGPT or Bard, it actually guesses the next word. And I showed a Google search demo. When you just search, it tries to guess. And even on our phones, when you're chatting, it is trying to guess the next word. It is generating the word each time, right? And how does it generate the right word? So it looks like it's talking continuously. One aspect of it is that the mental map in the foundation model. The second aspect is what do you do from there to build to an application level is what we're going to see today. So the question is, are large language models neural networks? I'm trying to get to, do they have a relationship to traditional AI? Because a lot of people have excitement for generative AI and is thought of as a new thing. And we've learned about machine learning and deep learning and computer vision and all the different models from the past. So much work has been put in. How can somebody build a model, a foundation model of the world of language from everything that's out on the internet? Not that it's a right thing, because that comes with its own problem, but that's how it's been built. How do you build it? It is built as a existing neural network, but using a transformer model. And last week I spoke about the transformer models. I'm not going to repeat that. And everybody who's here, if you want, you can raise your hand, you can speak up, because we have a small invited group here. So it doesn't matter if you want to speak up, as long as you're okay to be in the recording, because that's the only catch, right? Okay, so large language models are essentially neural networks. So, so what data trains the large language models? What is the data that trains language models? Come on, guys, I want to build the part 2 of this, so I need to see some answers of, from part 1. Okay, and thank you everybody who's here. I see more comments. Um, yeah, data from the web. What is data from the web? So uh, typically when I'm saying we are going to have a chat and a chatbot, right? And we want to or you want to build a machine translation. So what is the large language model? So when we say chat, let's take a very specific one. ChatGPT was built on GPT 3.5. So what is GPT? GPT-4 became multimodal. Multimodal means um, it has all kinds of data sources, right? Not just only language. So when we're saying language model and it is built with language, what is the data from the internet? Data from the internet is the right answer. Thank you. So yes, it is Wikipedia, all published papers, documents, all of those. What are those? So we have generative AI that can generate music, generative AI that can generate code, generative AI that can build chatbots. So it is trained on content from the internet. But on the internet, you have videos, you have images, you have audio files, you have random data stored. Unfortunately, and then you have lots of documents and stuff. So what is the data? So because at a fundamental level, uh, the computer can understand it digitally, it can understand ones and zeros, so it understands numbers. And so everything that we are going to use to train a model is going to be converted to numbers. So thank you for the comment. So it's data from the web and it's all kinds of documents. um, I see another comment here. So okay, so yes, so today's models, latest large language models, are multimodal, meaning they have image and language words in it. So the latest this week is with ChatGPT. They've opened up an interface to your mic on the phone on the ChatGPT app. So when you talk to it, it will take that, and what does it do? It takes the voice, converts it to text, and then it takes the text, and then it does regular chat, and then it comes back with an answer, and it chats back. So within second, you're talking to it, and it's answering in text. Um, so that's how it is. It's like talking to your kids. uh, so that is multimodal, where it is now taking voice input. It can actually understand images too, right? And I'm, for all practical purposes, I want to focus on understanding large language models from a textual context, and maybe a little bit of data too. Okay. So the answers are right. So it's, if it's everything from the internet. But when you chat with the chat bot, the most common example, it's very easy to think it's all only language. So thank you for those answers. I wanted you to understand that in its brain, it's essentially numbers, and when it's numbers, whatever is it's trained and converted to number, it's going to take it, whether it's an image, whether it is words. But typically people think large language models is language, means words. And so that's how even I was explaining its words and the relationship to other words. When you make it multimodal, you start training with other modes of data. But for all practical purposes, when I'm talking to you about how it is built under the hood, I'm just going to use the words and language. Okay, so there's lots of documents, and it's trained on those documents. Or there are people from the enterprise who are saying, hey, I cannot just take an API from the web and put my enterprise data and ask it to go make sense of that. I need to build my own LLM. And so there is movement to build your own LLM with your own data. What is the catch? Why is it expensive? Why is it expensive to build LLMs? I'm very happy with the chat here. Okay, so why is it? Somebody is actually, one of you is actually replying in direct message to me on the chat. I don't know if that's intentional. If you want to, that's totally fine with me. If you actually do it as a regular chat, then it will be in the thread that all your fellow webinar students can also watch that. Um, it is compute intensive. It costs compute power, also time. And why does it take so much time? Why is it a big deal? Why does it take so much time and GPU power to build these models compared to, just you go build your machine learning and you build your classification models and stuff? What's the big deal? What is it? it, because you're all chatting here on the Zoom, I feel great because I have a very engaged audience. But for those of you who are watching there, it feels like I'm just talking to myself. I did that with Sudha Live on Friday, where I was just talking to myself because I was on mute for a little bit. I edited it so you won't see it. When you see the video, you won't see that the mute portion. Okay, so the answer is it is very expensive. It takes a lot of time. It takes a lot of compute time because it's building a neural network. Lot of you data. If it is taking a lot of data, it's large language models. And we discussed this last week. What is the large? And we said the 4 V's of data, and it is focused on the large, essentially, on the volume, not so much veracity of the data or any variety of data or anything else. So large volume of data. So it has to, process that much of the data. But it is, Yash has this, that it is not just the large volume of data, but there is one more. Yash says tokens. That So the words are not just taken as words of dictionary. It is broken it into chunks of words or parts of words called tokens, so that you have even size of words. So one word could be, ambassador, it's a big word, and I am, and I is a small word, and am is a small word. So instead of mapping a dictionary word one on one to a number, the words are tokenized or chunked into equal size characters. And that's how the model is trained. And so there's a lot of tokens because of the larger volume of data. That is one. What's the other one? Because of the way the newer language models are built using transformer models, it has a lot of parameters. And you see that about that the GPT, I think, was first when GPT-3 was 175 million parameters, and then the latest one is like a so many TB of parameters, and the numbers keep going up, right? So what does a parameter mean? So we're talking about large language models. We're saying it's trained from data from the internet. We establish what the data could be. The computer understands only numbers, so the words are tokenized, and the tokens are given a number, and that's how it's trained, right? And it has a mental map of different words or different tokens as a relationship with each other, so you can retrieve that and then build out your next word. It is not recalling those words and then spitting out the same words. That is a big difference from machine learning from the past, right? That it is generating, it creates a mental map. Based on that, every time you chat, it is generating the next word. So even when you get a summary of this webinar, it is going to generate the summary. It's not going to take my same transcript and literally, like, and just send you the transcript in a nice packed format. It rewrites that. So it's very interesting to watch when I'm having this conversation with you. And I say, I'll get this to you. It actually makes a next steps and action items and puts all my names and said, Sudha promised that she will send the deck of this webinar to everybody. And that's a next step. So it is generating. So what is a lot of parameters? It is in the way the mental map is made and it is stored, and it has a lot of parameters. So we started out. My first question to you was, is an LLM a deep learning model? It's a neural network. So yes, that's established. It has lots of parameters. What does that mean? What does lots of parameters? What are these parameters? We covered that in last class, and don't worry about it. And it's a very complex topic, and there's a lot of noise and content out there. So it's very easy to kind of like think something, and then you kind of dig in, and it gets confusing. So the weights and biases. Thank you for that, Ritu. So what are weights and biases? So weights and biases is what is contributing to the parameters. Okay, so I'm going to share my screen here. Um, okay, so the language model is a mental map of all the words that's used in training. Its words are tokenized into chunks of words, and it is connected all that and says what, how is it related, and what's the big deal with the chatbots that's created from LLM models compared to chatbots from the past. It's context. Yes. So it understands context, which means it is much more, as long as you're in the same session with Bard or ChatGPT, it will know what you're talking about. You get out of that session, it starts again, right? It is retaining that context within its memory, within the session, right? So that it understands context. So when I talk to Alexa and say something in 2 minutes, she'll forget and she says, I don't know what you're talking about, right? So that is possible because it is trained, it is stored in a transformer model, right? Okay. So I'm going back to share my deck now. So essentially, we established that it's a neural network. So where I've gone back is I'm still revising from last week, and we are looking at understanding language models. It's trained by internet data, words, and words are tokenized, and then they're stored as numbers. Okay. And they're stored, and it is essentially a neural network. This is very important because what we are going to do is we are going to build up on that. This is the training that's already done. So all these companies, the open source models, the paid models from different companies, they are essentially giving us, they've spent a lot of compute power. Lots of trees have been cut to make this happen, and they've created this large language models, and then they're saying, here's an API, use our API. No, use our API. And so that's the world we are competing, right? And they are competing for us to build on one of these. And so today we are going to go to the next step to say, how do we build on top of these? Should we build on top of these? How do we build applications? What kind of applications are possible? What does it take is where we are going today, right? So it's important to understand. So when I'm talking about whatever I'm talking so far is still under the hood of how LLM works, which means it is still how it was trained by the data scientist who built this. So it's very, very important. I say this to all my classes. When you are talking about AI, when you're talking about building stuff, understanding AI, it is always important to understand, are you talking from a data scientist point of view, where you're building the models, you're interested in the model performance, and your whole way of approaching it is different because your role is to build this. So essentially you have stats background, you're a researcher of some kind, you're building those models, or you're it's called pre-training, when they did the training from the internet data and they created the large language models. And that is a different role from when now you see GPT and Palm and Bard and all of them, and you say, now I want to build this. I want to use this. I'm going to prompt, like prompt engineering that Robert Schwenker was teaching us. I'm going to prompt, or like Yash was teaching us last week, and say, I'm going to prompt and make ChatGPT build a recommendation system. Or I'm going to do something else, right? That's the fine tuning that I'm going to get to today. I'm going to build an enterprise application, build my own chatbot, build my own mission translation. I'm going to do something else that is feasible with these large language models. That's to get to the application layer, to make it to work for you, is what I'm talking about, right? So, but in the first part, which I'm still summarizing, I'm still thinking about how it was built. How did the data scientists build it? They use words, they trained with words, tokenized them, and then created embeddings and created a neural network and created a mental map. That is all in the training. That, we don't need to know that typically, but I want you to know, because we are going to do something else in how we are going to build it. I want you to understand the brains of what is the model that's given to you. I do not want you to think of this as, I don't need to know what's under the hood. It's an API. I just call it. I need to know how to call the API. What technology is my interface available? That's not enough, because it's still changing a lot. I mean, it is transformer models inside, it's deep neural networks. Not much is changing on the inside. But when they say, it is built with so many parameters and mine is better than the other, you need to know what those parameters are. So that's why I wish for you to know the nitty-gritty details of it under the hood, even if you're not the data scientist. And it's fine if the data scientist can do that. So where we stopped before I came to this topic is about the parameters. Parameters are the weights and biases. What are these weights and biases? So even when we looked at computer vision, when we try to understand neural networks, essentially each of these are neurons. This is how the data scientist is training the model, right? They are inputting a layer and then they are out getting an output of a layer. So if you want the model in the deep learning model for LLM to understand language and talk to us, they must have given a lot of words or tokens of pieces of words, and then they must have said, when I give one word, what is it going to give me as an output? So I go talk, let me go back. I stopped the share. So I'm going to go back. I find that easy to always do an exercise, right? A hands-on exercise. So let me come back, share my screen. So I don't want to talk theoretically about the uh, language models. Okay. So you can interact on your phone, your autocorrect and all that, right? If I say how, and it says how many airports in Toronto, I don't know why it says that. How to get to my LinkedIn live past videos that I had searched. Okay, this has my past, right? But how many steps in a mile? How old is Taylor Swift? Definitely that is not mine. How is how is no how am how am I supposed to live without you lyrics? Bad English, but how am I feeling? How am I going to show up, shower, shot, show you the inside of a new car? Nope, I'm not going for a new car. So I'm doing this exercise to show how it is guessing. Neural network for it doesn't know where I'm going after this, for LLM. Okay, so basically that's what I was going. I was trying to show you LLM working at an application level. In this case, it is guessing the next best word. That's what it is doing. So coming back to what I was sharing with you in a neural network. So the way they must have trained the data scientists for building the foundation model, the LLM that is available as API, they must have trained it, and they must have said, okay, here are a set of words from all the words from the internet. They tokenized it and they fed it as input layer, and they wanted an output layer. And then it has multiple layers where it passes the knowledge, and that's how it finally guesses the next word. So I was trying to show you when I said how, and it am, and it tried to guess. So when I say how, it says am, and then the next word, right? It kept on guessing the next word. So that is what the neural network is going to give me. So when I have a bunch of input, it is going to give me a bunch of output. How is it going to do that is what the training is. So to make that happen, there are these concepts of weights and biases. So when it is actually got a bunch of words and it transmitting that what word is important, right? How is it going to actually transfer that knowledge, right? From each. So it has a whole dictionary, it has a whole stream of words and tokens from the internet that has been trained and fed as input layer, and it is guessing out of all the words. It is saying how am I going to show, and it's guessing how did it find that right word. That knowledge of how it propagates which word. Remember, in the brain of the neural network for LLM, it is creating a map of what word is associated with every other word. So it is a game of probability. And it says, when I say one word, the chances of this word, the next word, when I say how, and then when you say am as the next guess, the word am has higher probability of being next to how compared to everything else in its training. It depends on what it's been trained. Remember that. So that it's understanding which word should it propagate, which token it's propagating is the weight. And then it does this training as many layers. It goes and then it gets an answer and then says, oh, I guessed wrong. Now let me do it again, because this is an AI. It does this again and again in multiple rounds of learning. And so it back propagates and says, no, no, this was not right. I need to go back and find out what was the input. So that it actually does this front to back to front in complete learning. So what it propagates back as is the bias. So that's the weights and bias. So at least I think that's enough for us to know to kind of move forward, right? And then the parameters I was telling you, BERT has 345 million parameters. GPT-4 has cut more trees than others and is at 175 trillion, and it's like a game. So unfortunately, the more the parameters, what do you get? Why is more parameters still a good thing? Unfortunately, from what we saw, right? Parameters is weights and biases, and weights is how it is transferring in its training, not when we are working with it, not when you're calling the API, not when you're building the application. In its training, when you get an LLM and say, hey, I'm going to use this API, and this is the underlying LLM, it has a lot of parameters, right? It has the more parameters it has better reasoning, right? It has better understanding of the relationship between the different words, and it can retrieve those words faster, so it can do a better guess of the next best word for us, right? So the more parameters, it's because of the transformer model, it can definitely do better reasoning. So thank you for that. Okay, so we've revised back on what the model is, and the other concept is that um, the tokenization, it's stored as word embeddings, and it is converted to a number, right? And when I say it in its mental map, it has a relation of every word to every other word. It is not just it's not like each word is stored as one number. Each word has a relationship to every other word. So that means it's a matrix, and it's a vector of multiple numbers. For each word, it's a vector of multiple numbers. And there are various tools that will do that. There's Python tools that will do this, but there are various exercise of thinking about how this vectorization is done. I don't want to go there, because this concept of word embeddings and vectorization is not new. It's been there around for many years. Even there is one tool called Word2Vec that is very famous. That's only English, but it's been around for a while. And so I don't want to go into how will you build vectors, because if you are a linguist and you say, oh, I want to train and I want to understand, you're saying language is the data and it's bag of words, and I want to now convert that to numbers. How do I do that? And there are these tools, and if that is of interest, we can go play with that, or look at multiple options out there. If you're a linguist, or you're looking at language data and you're going to convert that, you will need that even when you do your fine tuning. But I'm going to park that track of how do you go build vectorization for now. Okay, so we've established what we did last week, and I'm going to continue on. If does anybody have any question before we proceed? So we looked under the hood, we looked at words, we looked at weights and biases, and we said so many parameters. It's a collection of these. It's made as word embeddings, or a number for a word as a vector, and there are tools that will do that. And then we said, how is it stored? Is language transformer model. We looked at common models that's out there. So this is where we left. So pre-training is where we left it, right? This is what we did last time. So now we are going to go forward, and we are going to now build applications. So now tell me, what are these applications? Give me an example of what are the applications that you can build. I'm not talking about enterprise applications of different kind, but what can you do with LLMs? The most common one is ChatGPT. So that's the clue. But what are the kind of things that you can build with large language models? Why is it a big deal? You can do machine translation. So in machine translation, what are we doing? So there is a concept called sequence, right? So we have words, but we have a set of sequence of words. So remember, we said input and output. So I'm still thinking. So I've gone out of the data scientist work of building the pre-training for us to give us the model, but I've not gone yet to actually going and building the application. I want us to think about, okay, now I've got this LLM. It's a neural network. It's words, vectorized words. and it is somehow they vectorized it to do this large training with large volume of data, and they have weights and biases, a lot of parameters, and that's the condensed learning is what is given to us when we access a large language model. Cool. Now I want you to think about if you what kind of applications can you build on top of it. So you can do machine translation. ChatGPT is a chatbot. So there are many intelligence chatbots, and it is context-aware chatbots, right? That is the thing. Summarization, the one that we are getting from the AI assistant from Zoom. Yes, summarizing the knowledge base and providing Q&A are two different things. Thank you for that, Bob. So one is if you're asking the AI to say, here's the transcript from this Zoom, which is series of words, and now it's an inference, right? This is the model already exists, so they're taking a foundation model, and now they're going to say, okay, now I'm going to run an inference and build an application. So that's the important thing. So the data scientist is building something in training, ready, tested it out, and then say, here's the model available as an API. Now it's in production, it's an inference. For us, it's for all practical purposes, it's like a piece of software. Now we're going to access it, and now we are going to build application on top of it. So it's very, very important that when you build applications, you are operating in inference. And why? Especially with language models, if you go to train, it's going to cost so much compute cycle and how many tokens. When you run it, even if you build an application and you run it, it's going to cost, because that's how it is being, the business model is they're going to charge. When they run it in the model, it's going to go in its brain, scan and find you the next word, and then do the chatbot. It is doing machine translation and summarization and all that. So because of that, it costs. Again, when you run these models, it's expensive. When they trained it, it was expensive. Now when you're running it, it's expensive. So if you're building application for your company or your startup and you want to go do this, even when you're trying this out, it is very important to know you'll hit a limit, because all of these are giving free up to a point, so many tokens. So you can actually do inference with only so many tokens. So if you're just going to test it out and play with it, and then by the time it reaches your customer, you run out of tokens. Every time the customer comes, and if they are just chatting with the chatbot, it's going to cost money. So it's because it's going to cost tokens, and then that's how the APIs are charged. So it's important to know that. Okay, coming back to the application. So machine translation, summarization, chatbot, and then providing Q&A are two different things. If you're summarizing an input, so this is where I want you to understand. We're giving a sequence of words, and what are you getting in response, right? That this level you need to know before you go onto the application to build out the actual application. Let me go back here one round, and then we'll get into the tactics of how you do it and fine tuning and whatnot. Okay, so there are different kind of domains. The domains are the machine translation that you can do, chatbots you can do, and all that stuff, right? And so there are different sequence. So for example, if you're doing machine translation, that was one of the example, you're actually sending a set of words, which is a sequence of words, and in response you're getting a sequence of word back, right? So let me go back and look at Google Translate, right? Translate. I know I'm not sharing it, right? So I'm saying I'm going to translate from English to Spanish. Okay, let me. Yes. Oh, I am sharing the screen. Okay, good. Where did I lose my Google Translate window? So let's make it more fun. Okay, so I'm going to do Spanish to English. I'm going to say, hola, ¿cómo estás? Right? So this essentially says, hello, how are you? So here is a sequence of words, hola, ¿cómo estás? And it says, hello, how are you? Right? And so it's...
That tab is not seen. That
Oh,
tab is not shared.
oh, sorry about that. Okay, thank you for that. Okay, so now you can see it, right?
Yes.
Okay, let's say something else. I say buenos dias, which means good morning, right? So so the set of words I'm giving here and it is giving the set of words back. So I give a sequence and it gives a sequence back. So in machine translation, essentially, I'm giving a sequence and it gives a sequence back. So that's what I want you to know, that intuitively, you don't need to think too much about it, but it is important to intuitively know before you build applications for your enterprise. Or now you guys are seeing my slide deck, yeah?
No.
Okay. Yeah, now you should be able to see it. Okay, thank you.
Yes.
Okay, so beyond understanding how training is done and word embeddings and how they're vectorized, the next step you need to know is when you're thinking about application, like somebody is commenting, yes, it can do summarization and Q&A. Summarization and Q&A are two different things. So if you're sitting and thinking of an application for a startup, or you're sitting and talking to your company and say, hey, let's do summarization. Doing summarization and is different from doing Q&A. Why is it? So I showed you translation. So in translation, it's a sequence of words and it is predicting. So when I say hola, ¿cómo estás? It actually said the English equivalent, right? Hello, how are you? But it is a prediction in its brain. It made a prediction. It did a sequence to sequence prediction. Suppose it is doing sentiment analysis like a product review. And it says, here is a whole document of customer chat, and now I want to know whether this customer is happy or sad, right? It is predicting whether it is going to just give me a label back, positive or negative. And that means it is taking a whole sequence and it is just giving a label back. So that is a totally different thing in domain, right, in its brain. The third thing is when you do a chatbot, when you're doing Q&A, it is also doing sequence to sequence, right? So it takes the whole, it chats, you ask a question, it replies back, like we were doing with the Google search, it's giving a sequence prediction. So it's important to know that, right? So now I want you to think about when you say summarization, what kind of task is it? So we saw sequence to sequence, sequence to label, uh, and in fact, when you it can, in the past when it did sequence to sequence, it was making predictions. With chatbots, it is doing sequence to sequence generation, right? It is not, it is generating those words. So is it sequence to sequence? Is it sequence to label? When you're doing summarization, so all the chat that we are having here as not the chat, the transcript of our entire session, or you are having a whole knowledge management document library in your company. Now you want to feed it and you want it to give you summaries. So when any kind of document that is, it's going to give us a summary. What's it doing? What kind of sequence is that from what we saw? Anybody? You can add it in the chat. And can somebody keep an eye on the LinkedIn live also, because I want to make sure that I answer the questions there. And you can bring it here for me. Okay, so what
Yes,
kind of,
I'll do
yeah.
that.
Yes, thank you, Yash. And so what kind of sequence is it? It is sequence to sequence, right? And a common model, one of the LLM models that is used is T5, that is used for this kind of purposes. So one of the things we've done in our past is to understand the models, understand the application, get to the application layer, but then you have to map the model, right? So nowadays what people are doing is they just pick a model, try it out, and then they reach a point where they say, this is not doing translation for this language for me, because it's not got enough of that language knowledge in its brain, so I'm kind of stuck. So there's a lot of machine translation work that is stuck like that. But the most common thing people are doing is they're using text summarization. So the other thing is that the summarization can be very simple, extractive. It just picks up words from there and it just gives you and it generates, right? And it or it can actually build an abstract. It can be a little bit more intelligent. What is the difference between the two? So we are talking about feeding large volume of data, and the AI, like the Google, like right now what we are seeing in Zoom, that you're going to get a summary, it's just going to give you a summary of the transcript. So it could actually pull information from there and extract it and then say, okay, here is the summary. So what I see from what I'm getting from Zoom has been extractive. It's very long words and lots, like it's huge, right? If I'm running this for an hour, it's huge, and it's giving that, right? So, but it can be abstractive. Abstractive means it can we can actually not just give a lot of volume of documents and say, hey, have all these documents, now summarize it, and it gives this long stories, because it's not really saving time for me. So it's important that the minute you get to an application layer, you have to think about, why are you doing this, who is the customer, what is the value. So if it is giving is giving a summary, it is, so yes, if it gives a long-winded version of the summary of this session, it's okay, because it's capturing everything I ever said. And it's not a bad thing, because if you miss this and you want to come back watch this, instead of watching a 1 hour video, it might be easier if you just skim through the words. It might be faster for you, right? Whereas if I have a lot of knowledge in the company, and it is giving, right, then I wanted to do something more, right? And so I might want to train it, saying, this is how I want you to extract information, and I do not want you to just give me a long summary. I want you to extract information that is actually an analysis. Somebody was telling me there is a whole method of feeding documents, research papers, and then get extracting summaries from it, which means you have to train. So when you read a research paper, you have to know what is the argument, what is the analysis, what is the key pieces of that. And so you might want to train that. So how do you do that? So that is where we are going. So there are multiple options, right? The easiest thing is you take an existing chatbot layer that has been built for you, and then you actually do prompting. And there's a lot of wonders you can do with prompting. Okay, so that's what Yash was showing us last week, right? So you could just do prompting. There is another, or you can do like a search and query at a prompt level. So that is called retrieval augmented generation. And the thing with this whole tech world is we are full of jargons, and we come up with new jargons per day. So RAG, it is called, retrieval augmented generation. And so that is still at a prompt level, right? It is generating, but it is searching. You have a knowledge base, it is searching. So the main thing with LLM is it's documents, and it is content full of words. So when you build, when a chatbot is magically built and given to us like ChatGPT, we are prompting it and getting it. So I'm going to jump straight to prompt tuning, because as long as we are prompting at an application level, we are querying it, it gives us an answer. It is searching and giving us a little bit more in a more augmented way. Or the prompt tuning is again a prompting technique. I briefly mentioned this last time, where you just don't prompt and ask it a question. You prompt it very intentionally, so that you kind of adjust the weights and biases inside. Suppose the LLMs are known to be biased because it's built with internet data. So if you want it to not be racist, you want it to behave a certain way, you could actually prompt tune it just by your prompt to adjust. Either you feed some words or you feed some numbers, and you prompt it so that the output looks like what it should be. So that's the prompt tuning. So the prompt tuning is now becoming one of those explainable AI kind of techniques for the world of LLM. But I want to go to fine tuning, because we have a demo that we have somebody ready to show us. So to fine tune, we have to understand the relationship. We said it's a LLM, is a deep neural network. But going back in our past world, machine learning was about feeding data. And this is again the data scientists, how machine learning in the brains under the hood of machine learning was supervised learning. You knew the answer, you said these are the factors, and you build the model. And then that's how machine learning was taking historic data, past learning, and then build the model, right? And deep learning or neural networks was done with unstructured data. And it's easy. I love cars, so I show that. But even language data, the way the LLMs are built is unstructured data. Why am I going back to the past of machine learning and deep learning? So the connection between that and generative AI, not just LLMs only, it could be generating images or voice or music or anything else, code or anything else, is called semi-supervised learning. So it was supervised learning when you knew the answer, you knew the rows and columns and what the answer should be. You knew it was a dog or a cat, and you could see the answer. You just made the AI deal with large volume of data, make predictions of weather and all kinds of things, right? Unstructured data it built neural networks without, in huge volume. It was looking for patterns for you on its own. So the language models are built as unsupervised learning, as foundation models, and then you take a small data set of how you want it to behave and you fine tune it. So that exercise, that's called semi-supervised learning. So you do the foundation model of supervised, unsupervised, and then you do supervised on top of it. And there are multiple techniques of doing that. uh, so one is, you can take the existing model and you say, I'm going to keep everything it has, only the last layer of the neural network I want it to change, and that is called fine tuning. So I'm going to stop, and I have somebody who is here, who is going to show us a demo of fine tuning. Yash.
Hi, Sudha.
Yeah, is
Uh,
Yashwant here? Do you want to
yes,
let me give you control?
Yashwant is here, and I would like to briefly tell what is the demo about and also give an intro to Yash. Um, Today, we are doing a fine tuning exercise in the domain of legal using the data that we get from the websites here in India, which is related to the Indian Penal Code. So, Yash is here. Yash is an engineer, an NLP
Indian,
expert.
sorry, Indian Penal Code is Indian law,
Yeah.
Indian Constitution. Okay.
So, Yash is here. Yash is an engineer and NLP expert from Bangalore. And he has startups in 3 different domains. And he's the Gen X of trying new stuff. He has a lot of expertise in generative AI. And today he is here to share his knowledge about the live demo that he wants to give to us. So he'll be showing a live demo to us so that we can understand what is done step by step.
So
Over
he's
to
going
Yash.
to so he's going to do fine tuning using legal data.
Yes.
Okay. Um, Yashwant, do you want to come on camera? So Yashwant Vanama, right? I want to make sure that
Yeah,
since
you can call me. Yeah, you
since
can
we
call me
have
Yash.
Yash, the Yash word is taken. We have one global
Okay,
Yash.
fine. You can call me Vanama. It's my surname. I am happy to with
No,
that
no, no.
one.
We'll call you Yash. It's okay. Okay, I'm going to remove this Yash off camera so we get Yashwant on air. Thank you, Yashwant, for finding the time. I appreciate this. So take it away.
Yeah, thank you. Thank you for giving this opportunity for me. And I would like to first introduce myself so that you will get a brief about me. As Yashashwini said about me, that my name is Yashwant, and I'm from our Silicon Valley of India, that is Bangalore. So I'm a data scientist and also an associate manager at the age of 21. So I be proud of that. So basically, I do different types of expertises in NLP, so mainly based on the language. So I do research on different expertise in how language should be connected with AI, like in Indian languages mainly. So basically, I do research mainly on Telugu. That is my fundamental language. So if I talk about my expertise, I am good in NLP and also our latest framework that we are going to see today, that is LangChain, which is a bridge between our ChatGPT and our knowledge base. So I want to show you a quick demo of it, and I want to show how we have to use and at the potential of ChatGPT to its level. So today I'll show you that very clearly and with small important tricks that people can use it daily. So I've been working on LangChain from last 4 months. It's been released 5 months, so I've been working it in 4 months. So I got a pretty good grasp about it, and I continue on doing it. So I'm glad that I got this opportunity to show all you people that how you can use the ChatGPT to utmost its potentials. So if you can allow me, I'll share my screen and I'll show you.
Yes,
I
please
think
go
I
ahead
was,
with the demo.
yeah, I was disabled with
Okay,
the.
Sudha, you want to say something?
No, I'm just turning on access. I was just saying, give me a minute. I need to make him co-host. Okay, now you should have access, Yashwant.
Yeah, I do have access. Thank you. I hope my screen is shared.
Yes.
Yeah. Okay. So I have created a small PPT so that I won't miss any point. So I'll go with this PPT itself. So today I want to show you a wonderful and as Yashaswini said, it's on legal GPT. I called it as legal GPT, and also you can call it as lawyer GPT, which is a use case that will help for lawyers. So basically, we can train this on lawyers' data, that is cases that happens between the courts and etc. So basically, we can train this on lawyers' data.
Are you able to hear Yashwant, or it's just me?
I think we lost him.
Okay,
We will just give a couple of seconds so that he can reconnect back.
no problem, no problem. So while we are waiting for Yashwant, do you want to give the context of LangChain, the whole, that I was saying, this whole search and prompt and retrieval augmented generation, very briefly, right? Isn't that what LangChain is doing here?
Can you
Yeah,
hear
yeah,
me?
he
Yes.
joined back. I'll ask the question directly to him. So, Yash, can you tell more about LangChain? What is LangChain? Why do we need LangChain?
Okay, okay. I will come to that point in pretty soon. Okay, I will explain it. So LangChain is a framework like a Flask that we use, that how our backend and front end applications in Python be connected. So same like that, LangChain is also a framework that connects open APIs abilities to our knowledge base, so that it can learn from our knowledge base anything that you keep in that knowledge base, like your personal data, or it can be your like notions that your company uses is, and like for example, I will give an example where LangChain is pretty good use case. Like you have a full of people with who are developers and who are HR teams and etc. And you keep all your knowledges in Notion at one place. But you came with a new guy who wants to learn everything from the scratch about that project. But it is hard for the people that to understand what is meant by a certain things. So then what we do is we can create a chatbot based on that knowledge base, and we can ask questions on that project. So it is easy for the people who wants to communicate. So LangChain is a bridge between our ChatGPT and our own knowledge base. So it will do a pretty good interface between our mindset, like how we work, and ChatGPT, how we want to take that to extreme potential. I think this is answer.
Yashwant, so the Lang chat is actually interfacing with ChatGPT. So one of the things I was telling people is we could do prompting on top of an existing chatbot, or we could use an existing API like GPT and then do fine tuning with your own data set. So here you're saying
Yeah.
we are using our own knowledge data set, in which this case you're showing legal data. It could be company data to train the last layer, but you're saying it is built on top of ChatGPT, right? This is, yeah, I want to
Yeah,
understand.
like any LLM, you can take in LangChain, you can take any LLM, but basically we go with OpenAI, so it's a chat GPT. On base of top of
On,
that, we build it on.
okay. Okay, thank you.
Yeah. So I is my screen is still
Oh,
sharing,
since
or
you
is it
dropped
stopped?
off and came back, I think I have to give you permission again. So sorry about that. Oh, yeah, you have access. Okay. Yeah, now I think
Yes.
you're sharing
Yeah.
the
No.
screen. Yeah.
Yeah. Okay. I'll go with my PPT again. I think
Yes.
so.
Yes.
So as we know, can anyone answer why LLMs? As we are discussing with Sudha, so I want to know, understand that why LLMs. You might know what is LLMs, and you might ask the question inside the LLMs. But I want to ask people, what is LLMs? Basically, what you people think about what is LLMs?
Am I allowed to answer?
Yeah, anyone. I'm happy.
No, I'll give a chance to other people to answer.
Yeah, sure.
So we were looking under the hood of LLM. It's all words and everything, and word embeddings and whatnot. Now you're saying why LLM is a big deal. Why are we using LLMs to go access our own
Yeah.
corporate data? We are talking about accessing our corporate data, which we've been doing, right, with all kinds of existing databases and systems before, right, applications. Why do we have to do this with the LLM? Is that your question?
Yeah, no. Why LLMs actually? Why
I
you
see.
are thinking that LLMs are important for yourself, and what is the basic need of LLMs, and why it is important to our corporate levels or anything that we are using daily?
Anybody wants to answer, you're welcome. Um, it's showing me on the screen. Maybe you should get out and show yourself or show your PowerPoint.
I think, is it okay now?
Yes. Yes. I would guess it is how it can have natural language. It can talk like a human. That is one
Yeah.
that people are attracted to.
Yeah, that is great answer. Why LLM is so popular? Because it's like our brains. So, with a small example, I want to ask what you did on 31st December at the last year. You might come with this answer like, I am doing party, I was with my friends, I went to out with my girlfriend, did date that this. But if I ask you a question that is which was like from your childhood, like what you did on November 11th at 11:30. So I hope no one can answer that particular question that saying that, oh, I definitely don't remember this particular thing. Then this are that's why we came up with this AI missions, something that can remember our stuff or remember anything that we are teaching it, or that that in the words of computer it is learning, but actually we are teaching it. So since we are teaching it, it is learning as a kid. So but a human can forget that, but a machine can't forget it. So basically we are creating a brain so that it can remember some all the things that are from future, I mean from the history. So basically LLMs are, that's why it's popular, that it can be like a human, completely like a human. I hope this answers my question.
Yep.
So I will, yeah, then I'll go with how LLMs are like, as Sudha is saying, it is trained on large amount of data, that is blocks, code bases, and etc. Then this knowledge bases are came, so we can train that on data, and one LLM is created there. So it can be anything. That LLM can be specified to codes, it can be blocks or anything. But if you train that in a larger amount of data, then it is called as LLM. I want to give a specific example that I say to every people who wants to learn LLM. So basically, in the starting of machine learning or AI field, in the starting of era of AI, if you see, while we are going with the technology, the data also increased. So as the data increase, we can't remember completely. So that's why we created AIs to remember as we speak before, like why LLMs. So first of all, why machine learning is a question that generally most people had. So in the machine learning things, so what people do is that they will divide, or they will translate, or they will classify this particular knowledge, so that it's important for them that machines can understand these particular things. So then people came up with this idea. Okay, my mission is working very good in classification or predicting something. What if I have a data of text? This question raised for many people. Then they came up with this idea that is called as RNN, which uh, which is recurrent neural networks. So these can be capable of learning the things that is from text. So it can remember, it can predict, it can do something. Okay, now let's imagine something like that. RNN is trained on a page amount of data. So then people came up with this idea, what if I have book amount of data with me? Then people has gone people has go with this idea that saying, okay, now we can't do that, so we'll go for transformers. Then uh, library amount of data came, so they came up with this something called as a large models. So large models are evaluated because we have large amount of data. So this idea, I think we all learn what is what and what is what, uh, LLMs in Sudha's class. So I will directly go into my demo, that is legal GPT. I hope everyone is clear with what is meant by legal or lawyer GPT in my words. That is, it is helpful for lawyers so that they can understand how they can make it easier for asking questions for the lawyers. So here we are using a framework that is called as LangChain, which is a link or a bridge between ChatGPT and our knowledge base together. So I have some steps that I follow to create a project. So these are like importing some required libraries and loading the data, splitting into chunks. Chunks is nothing but uh, you have a larger amount of data, so you want to divide that into smaller parts. Like for example, you are a kid, okay? So if you're an adult, if there is a paragraph, you are trying to understand that paragraph, then what you do, you divide that into a sentence, right? That sentence is converted again divided into words. So then you can understand, okay, what is the relation between these words? Then you can come up with this, okay, this sentence has this meaning. And you do for the second sentence, you combine both of them, and then you create something that is like a summary for yourself. So to understand that, to missions can't understand it, so we create embeddings, that is nothing but numbers, as we discussed. And in my project we have to store those embeddings, and we will create something on QA chain. I will let you know what is QA chains and etc. In the demo itself. So so this is a collab notebook. So we can do our project on collab, which has GPU capabilities with the T4.
Sorry,
So
Yashwant. Yashwant, I have a question.
yeah,
So essentially, you said LangChain is
yeah,
a bridge between your data set and
mm,
ChatGPT. So what you're showing
yeah.
us is prompt based, essentially on top of ChatGPT, right? That's that. I understand that. Um,
No, actually, we don't go into deeper of prompt because it's in QA chains. They already written that what is the prompt requirements.
yeah.
So I won't show you that prompt, but basically we do using prompts in the
But
QA
are
chains
you doing
inside.
prompts? Are you doing prompts, or Lang AI
No,
is giving you the is
we we
it's doing
we
prompts under the hood?
yeah, it doing under the vote.
Is
It has its capability of doing it.
it is doing it is it so it is essentially you're doing it like a search, right? You're actually saying, here's my data set, I'm going to search this data set, but I'm using
Yeah,
lang chain. So it on top of chat gpt. So your tech stack is you're using chat gpt, lang chain, and then you're just it and you're using its own built chat prompt with your data set. Okay.
yeah, we can create our custom prompts also, so that
Okay.
we can create our custom chains.
Yep.
Like for example, you don't have QA, you need to make something that is not presented. Like for example, you want to make custom prompts, like you want to give recommendation system as Ashwini showed in last class.
Yes.
So you can create a complete recommendation system saying that you are in the prompt saying that you are my recommendation system engine, and you need to use your knowledge to give me from this particular data. You need to give me the recommendations for my particular data. So
Okay.
you can use that particular thing and create the custom chains for the recommendations itself.
Okay, so that's more advanced to create custom chain. So, but I see the
Yeah.
potential. The other question I have is, you're going to build, you're using LangChain on top of ChatGPT with your own data set, right? We were
Mhm.
talking about,
Yeah.
we could just have our own enterprise data, or in this case, a sample data that you have brought. Did you have
Yeah.
to prep the data, do a word embeddings, do anything with the data, or you just got the raw data that you're
No,
going to use?
there is something called as OpenAI embedding. So we don't do complete task. OpenAI do itself. For that also we have in LangChain a capability called as embeddings. So you can just call the embeddings into a variable and send your data inside it. It will do it complete task.
So
You
it
just
is
need to
doing
write
what?
5 to 6.
Yeah.
Yeah.
Sorry,
So
I didn't mean to interrupt. So it is
yeah.
doing. word, it is doing word embedding, but you're not doing a word to vec or anything else, right?
No,
It is doing
it
that.
has own capabilities for doing those things.
Okay, sounds good. Thank you. Back to you. Yeah.
I just
Yeah,
want to pitch in here.
there is one more
So
question I
in
think
the
so in the
chat,
chat.
Rabiu Ibrahim is asking, how do we do this LLM for low resource language? Maybe we can say that we will help him offline if he tries to approach Business School of AI. So I
Radu,
just wanted Sudha to answer it for him.
yes. Okay, I mean Radu, we can talk offline. Radu actually knows a lot of stuff. He's one of my students. He's trying to see a different application, right, to do that for other languages. So Radu, um, it is actually Rabiu, I think. It's not Radu. So Rabiu, one of the things we are so one comment is, you're seeing my face back on screen. Can you go back to your deck? Somebody wants to see that. Uh, um, my passion is this whole machine translation. So like I was saying, we could take a small data set and do fine tuning, or you can do some kind of prompting and search on top of an existing chatbot like ChatGPT for enterprise data or your own data set, or you could take low resource language and build machine translation. So that's a passion of mine. So we'll try and bring you answers on that. I think we today the demo is just going to be how to take an existing data set to do that. But that I have, I think in our past weekly wed, we had Muskan Mahajan come and show us how she's done this for a low resource language for English, which is a combination of Hindi and English, with Hindi written in English script. And she did that using Bloom Chat. So that is in our past recording. So, but I'm happy to pick this up because I don't have all the answers on how can we take any low resource language and go build a machine translation, because I'm trying to do that for Bari language to help another group from South Sudan. So I'll continue. Maybe we'll bring more speakers. Maybe we'll do more sessions on that. But thank you for that question, Rabiu, and I'm happy to follow up offline also if you're working on something specifically. Okay, so we'll continue on because we are going past time. So I want to see if we can wrap up in 10 minutes, but I want to go give it back to Yashwant to show us the demo that he's doing with Lang AI.
LangChain. Yeah. AI.
Langchain. Yeah, thank you.
Yeah. So today we are going into this code. So I have some required libraries that I will explain why. So first one is LangChain that
Yes,
as we
sorry
are
to
discussing.
interrupt again. Can you please increase the font? Can you
Sure,
please
sure.
increase the font?
Yeah, yeah. Is it okay now?
Yeah, this is
Good
good.
enough? Yeah,
Yes.
okay. So first one that I have is LangChain. So as we are discussing, that is important, and we need OpenAI to call the OpenAPI, OpenAI ChatGPT, and there is something called a stick token, and that is a requirement for LangChain. So and we are using Selenium to scrap the data and Fayaz to load the data. So I hope everyone understood what I'm trying to say. So I'll just connect with this and run. Yeah, it might take us a couple seconds. So,
Yes, what you can show is you can just show the output that you have already got, so that in the
yeah,
interest of time, let us wrap it in another 8 minutes. Okay.
okay, okay, not a problem. I will
So
just
you
show
can
you.
show what output you have already got.
Okay, I think that output, yeah. So my question
I
from
meant
this
for each
complete.
cell, for the
Okay,
steps for
okay,
each
okay,
cell. Yes.
okay, okay. So basically here I am doing in a shortcut way. So I want to teach everyone this shortcut way so that you can do on any website that you want to do. So basically indiancanon.org is a place where you can get the data for Indian penal codes and etc. All the cases that are related. But I will show you something different also so that you don't think it won't work for any other things. So let us go for something like openai.com. So if you can see this website, so so here after the .com, I will write just a moment. I think I will zoom this. So after the .com, if you can see, I will write something called sitemap.xml, which give you all the XML files that are seen on that website. So here, if you go, you can see all the websites, all the links that are connected to each other in OpenAI .com. That is like in research, if you can search, if you want from OpenAI this particular thing, then you can search for inside that website, and you can do it for any website that doesn't matter. So once you got the XML file, then everything in the code is like piece of cake. So to get this particular thing, people write like thousands lines of code in Python to get that XML outside, and then they'll go to this particular thing and retrieve this XML from that location and then use it. But I want to show it in an easy way so that everyone can use this particular thing. So if you can go this try this particular link, you will be redirected to that particular page itself. So this link will be redirection of that particular page. So all this you need is I think I have kept less than mark. That's why I got the error. So you can go to the websites. And here, if you see, you came to the website itself. That means this link can be useful for anything. So once I got this link, same like that, I used for Indian Canon, and I came up with this links, two documents. That's all, nothing else or nothing wrong. So I will show you this also. Same thing that I did for Indian Canon website, and I came up with this documents that I need to show you for you people. Oh, I think this is wrong. Yeah, this one, 37 I wrote wrong. So if you see this, you went to the case that is Ramesh versus state of Tirupa, and you got the output for ourselves. So now I will wrap up this how you can load it and etc. So from in LangChain there is something called as document loader where you can have different document loaders like CSV, Excel. So it's not only that URLs you can keep any type of data that you want, whether it's structured, unstructured, it doesn't matter. So since URL is an unstructured, so I'm going with unstructured URL loader from the document loader, and I am loading all the URLs inside it so that I can load the data. Once I loaded this data, I'm checking the data with the first one. So you can see this is same Ramesh versus Tirupa, state of Tirupa. That what we just saw. So you can just extract any type of data from any link using these small methods rather than doing this complete Selenium scrapping. So inside this particular unstructured URL, it is doing that only. But you don't need to do that hassle anymore because of LangChain made it easily. So once you got into the data, then what I did was, so as I said you before, how you'll understand a paragraph is you'll just minimize it to into sentence, then you minimize it into words, then so that mission can understand also in the same way. So for that only we are using something called as text splitter so that it has its own way to make the embeddings. So OpenAI can understand that how the vector should be created for its own benefits. So that's why we are using this. And as I said, chunks are like small size of data from large amount of data. So here you can keep multiple URLs, not only two. I just used two so that people can get easily. Then I used my OpenAPI key so that I can pass it to my OpenAPI. Then there is an interesting method that is called as creating open embeddings. So I hope Sudha has taught you all people like what is open embeddings mainly is. I mean, embeddings means like what is vectors and how it is useful for you. So embeddings are nothing but like machines can't understand our data in textual process. So we create something called as vectors. So to create them, we use this process called embedding. So then I store them in different databases. We have something like Chroma. We can store this in cloud also. We can have a Pyan for the industrial or some like professional way of doing it is in Payas. So I went for Payas, which is locally best. So I loaded all my embeddings and kept inside the Payas so that it can use as that particular thing. Now you we can there is LangChain. We have something called a chat OpenAI. So what this chat model do is it will answer like a chat, like you can ask questions so it can remember that particular chat and answer you back based on the human conversations. If you won't use this particular chat AI model, then what happens is it won't answer you in a particular way of chat. It will answer you in a way that is like a complete summarization or something like that, but not in a chat specific way. Like for example, what is Amazon? Then it will answer Amazon is a e-commerce. If you won't keep chat models, then what OpenAI LLMs does is Amazon is a e-commerce site. Then it will sell products. It also have something like cloud and etc. So this big amount of context will be given for you if you don't use OpenAI. I mean chat models in OpenAI. So basically that is why we are using chat models. So you can answer it in one step. I mean, like the only context that you need, not anything extra, so that you people can understand it very clearly. So I just saved that into a retriever, and there, this is the main part that we have to learn about. That is, in chains, there is something called as retrieval QA. So what does this particularly retrieval QA do is, it's like similarity search in your whole documents. It will go for similarity search, but there is one difference, that is it can understand the context level. So it can understand the context level and it will remember that particular context, what you want to talk about and how questions are framed and what it generally needs. So you can check everything with this retrieval QA method. So that's why we are using, and I just initiated this retrieval QA, and then I came up with this question saying that who is the defender for this case, and it beautifully answered that it's Mr. D. Sakar advocate. And you can go and check that particular answer, that who is our respondent. And this is my demo that I want to show you. I'm happy to answer all the questions that you people are ready to.
Thank you, Yash. Thank you for the demo. And over to Sudha here.
Thank you so much, Yash. This was really good. And, the whole LangChain concept is new. And uh, it's very nice that you showed a very succinct demo with a fixed data set. So if somebody wants to look at this, is this something that you will put this data and everything you put this on GitHub? Is there anything else of yours that we can
Yeah,
follow?
I will keep this in GitHub because since this is a demo, so I stopped it for until the demo. So once it is done, I'll send the link to you or Ashishwini so you can follow up to the students and etc.
Okay,
And they
sounds good.
can even follow up in my GitHub through uh, through my GitHub. I will be uploading all my projects. I
Yeah.
have done like multiple projects on LangChain recently. Like I and my colleague named as Setu, and also Ashishwini is mentoring. So we did some of the projects, nearly like 10 to 15 on LangChain. So it's like two are enterprise level. So one we are going to launch very soon.
Yeah.
So we hope we, and that's our dream. That's it.
So did you have to do anything to get the data set, or can you take any data out there? You created, you had this whole Indian legal system, right? The penal code that you're calling it, right?
Yeah.
And that data is like that. Can you take any public data set, or is there like anything that is required to test this out? Suppose anybody who's watching this says, oh, this is interesting, and it is on top of ChatGPT and it doesn't seem very code intensive and I can do this. Can they do this for any data
Yeah.
set?
So if the people had like as I showed just now, people had data in XML format, that how to get an XML, they can get it. Or else there is one more method that, as I said, it can load our traditional databases also, like SQLs it can load, or CSVs, JSON data, any structural data or unstructured data, anything you give, it can do it. That is the power of LangChain currently. So people are like investing more amount of time and creating more applications based on it. Like you can get, if you have a data of anything, like your for example, this lawyer data is there. It's in a book of PDF. Then you can use that PDF and train the R using LangChain. If you have multiple PDFs, then you can keep it in a directory and then you can do embeddings. And it's like you can do anything. You just need to
Okay.
have a data. That's
Okay. No, this is very, very fascinating. I love it that you can use so you don't need to actually have a vector database and vectorize your data or anything else, right? You can
so
just take real language and then you can feed it into this whole pipe.
Yeah, actually, you are creating the vector stores that is in Payas as I showed. You are just keeping that, but you don't need to do it for your hassle. Like you don't need to do embedding, tokenization, or regex
Yeah.
format, which format it should do, and etc. So it's directly like you can just take the data, keep it, and run all my code. Like I given you 10 lines of code, and your enterprise level of application is ready.
That is beautiful.
It's so
So, sorry, did you want to say anything else?
no, no, no. You are
Okay.
saying some
Now,
question.
this is wonderful. It's because I have written 7 books. And I have one book on generative AI. It's called Generative AI, a primer for product and business managers. It's a Kindle book, right? So I can output that as a PDF. So I'm just thinking it must be like maybe 300 pages or little less if, with the references and stuff. So maybe I can take a PDF of that, feed it, use your same code from GitHub, and then create a knowledge repository. People can come and query and learn about generative AI without
Yeah,
buying.
yeah,
Yep.
if you can see in LangChain website itself, they are creating a new project that is called as LangChat. Same thing. What I just showed, they just replaced their URL with their LangChain URL, and they created enterprise level what's bot, and now people are using it every day and asking questions on top of it, like what is LangChain, how I can connect this particular
To
question,
learn about
rather than
language.
asking yeah,
Yeah.
rather than asking it in the websites or Stack Overflow, you can directly ask to the website itself. So it's like a human for you. So now a LangChain human is there.
That is beautiful. So we need to wrap this up, but thank you so much, Yashwant, for coming to this, and thank you, Yash, for mentoring and introducing us to Yashwant, because this is not the last time we are seeing him. We are going to call him back. We are going to learn along with him. So thank you so much.
Sure.
So for those of you who are watching, especially if you're part of my regular weekly vid community, bit.ly/weeklyvid register will bring you here, get you Zoom link, and then get Paria's newsletter on weekly vid on Tuesdays. So one of the things that I would like to do is see who here wants to follow up, work with me. I want to take one of my books. Maybe I can take my IoT book or my generative AI book, and then feed this into LangChain using Yashwant's GitHub code, and see whether we can create like a knowledge management system. I've been wanting to do some kind of hands-on project. As a teacher, I'm always thinking of knowledge sharing, right? And we have so much content with all the lessons we do and the speakers we have here for many years. So I was just thinking we have to take a transcript of that and do something, right? That's what I was thinking, like a summarization type of thing. This is so much better. So thank you so much for doing this. I'm going to follow up with you because I want to do that and see whether we can create a chatbot to teach people about generative AI. And I want to see whether we can feed more data to it, not just one, right? Not just one book. That's I want to create like a whole knowledge management. So I appreciate you getting us excited about it and teaching us. Thank you so much. I appreciate that. And can people connect with you on LinkedIn? And will you be receptive to talk? Is
Yeah,
that all?
uh,
Okay.
yeah, yeah. I'm just
Awesome.
sharing my LinkedIn, GitHub. I mean, I'm sharing my website so people
Yeah.
can come.
Can you put this in the chat here, and I will make sure that I'll go put it on the LinkedIn also, because that is one, and then we can share it in the newsletter when we share this recording out. Um,
Yeah, this is my LinkedIn.
yes, thank you so much. Yeah, people can see that. Thank you so much, Yashwant. So there was one question. I thought it was Radu. It was not Radu. It was Rabiu Ibrahim. And thank you, Rabiu, for that question. So this is an existing document data that you fed, and then you did this, right? Retrieval search, essentially like a RAG that you did, right? Um, for
Yeah.
for
So
machine
RAG
for
is,
sorry, go
yeah,
ahead.
yeah, yeah, yeah. You are saying for
No,
missions.
you were saying RAG is, and I want to know if what I'm saying, this was RAG or not. Tell me more.
Yeah. So basically, RAG is like there is a person, okay, who has knowledge on something. So what I just created, LangChain is a RAG completely.
Okay,
So
that
it's like
yeah,
an agent.
yeah, that's what
It's
I
an
thought.
agent.
Right? Yeah. Okay, good. One of the things I like people to know is whenever a new jargon is thrown, I want them to kind of know it, because in a new field like generative AI or LLM, it's very easy to think you know something and then you hear some new words and jargons, especially three-letter words, and then you go, oh my god, there's like a whole world, I don't know this. So what you guys have learned is RAG. Essentially it's search and retrieval. You're essentially searching your own database or
Database.
your own document using, OpenAI on top of ChatGPT, using LangChain is what Yashwant was showing. So one question that is unanswered is about language for low resource languages. So you said Telugu is your mother tongue. Is it possible to take a Telugu language document and do this with the same setup that you have on LangChain, or is it English only?
No, actually, the current community doesn't follow with the languages that are other than English and
Okay.
Spanish. Just now they introduced Spanish like 2 years back, I think so.
Okay.
But still they're at the level of but there is one possibility that you can do it like completely remove the LangChain, and there's something called as LoRa, which you can fine tune your LLMs from the scratch. So you can do that, but not on top of LangChain, because LangChain is basically using our existing models but not fine tuning on top of it.
Okay.
So if you want to fine tune something, then you can use something called as LoRa, or Microsoft has released 2 days back a blog that is called as Autogen. So
Yep.
what Autogen does is like the same thing. It has two agents. It can communicate with each other. It can learn from each other. It can do anything you want, but you can train on that. That is one thing. And there is something called as long LoRa that is released a day back, I think so, in code with paper there. So I have read that paper. So they are saying that now you can go until 40K to continuous token that it can produce. So it's like massive upgrade in LLM. Like you are going to see that complete change of LLM in next month because of this long LoRa. Our whole LLM models might change. And there is one more library, I think so. My colleague has sent it. I don't remember the name, but it is like fast computational. Like it will do 40 times faster than what we generally see. So it's like huge development in this like in this week, that seven papers has released, and it's like too good right now. LLM stands in top of, and there is one more person, that is Qualcomm's AI researcher, from senior researcher, and he has mentioned in his last podcast with Sam, saying that they are going to work on visual groundbreakings where LLMs can see what it is learning. Like uh, currently, LLMs doesn't know dog. What is dog? It doesn't know. It's a number for it. But what if LLMs can see? It has eyes. Then it can make that LLMs to a part where it will learn that dog. Okay, dog is mine. Now for example, that visual breaking, like a car is going in a traffic, a bus is there, and bus is removed, what it will do. Now the scenario can't LLM can't imagine right now what we have in ChatGPT. But with visual breaking, it's we are going to make completely in different level. Like you can use it in army use cases, satellites, and everywhere. That the AI going to change it in next few months. Mark it.
That's awesome. Thank you so much. And for those of you who are watching here, we're going to wrap up this part two of our LLM webinar. And I hope we've left you with so much excitement because Yashwant is so passionate about this. And we've actually opened up more questions because I always like it when you learn something and then you kind of go to the edge of learning and you feel like, oh my God, I don't know all these other things. So I hope we gave you enough confidence to do something. And then we've kind of introduced the promise of the upcoming world out there. So that's an exciting place to wrap up. So we will be back next week. Susanna Raj will be here at Weekly Wed, and we'll pick up our conversation. We're going to go in a different direction. We're not going to continue this webinar because we want you to take what you've done, learned in the last 2 weeks, do something with it, go watch it, come back, and then we'll pick up this thread again, so we kind of don't make it too intense in the same direction because there's too much happening. But I also host a weekly wed, not a weekly wed, something called Sudha Live on Fridays, where I'll bring the latest that's happening in the week. Not with as much excitement as Yashwant was saying, but I try to take something that's happening in the latest generative AI space, analyze and come up with my own analysis of it, and then and focus more on opportunities. Are there call for papers? Are there jobs? Are there events where opportunities you can learn and stuff like that? So that would be a more of a discussion with me, that I will come and bring some of this, but I need to go play with this a little bit to get smart about it before I talk to you on Friday. So with that, I'm going to wrap up, and stay safe, everybody. And thank you so much for your questions. And for those of you who are new, who joined in, make sure that you are signed up for the newsletter. bit.ly/weeklywed registration will get you the Zoom. Or if you just follow Business School of AI on LinkedIn, you should get the live stream. So I'll come back to the live stream. Hopefully, Yash, Yashwini, between us, we'll come and post some of the links. Especially, I want to make sure people connect with Yashwan. I'm not connected with him, so I could not tag him, but I wanted to thank him publicly. So thank you so much, Yashwant, and thank you, Yash, for bringing Yashwant and mentoring him. We appreciate this. And with that, I'm going to wrap up. I'm going to stop the live stream. And everybody who joined on the Zoom should get an email with the summary of this chat, including all our discussion. It doesn't give the URL and link. It is more the transcript from the conversation, but you should be able to get that. Otherwise, ping me back on LinkedIn at the chat, and or if you're on the newsletter. So I'll make sure that you get it. Okay. And I want to see if there are people who want to work with me to take this idea of LangChain from Yashwant's GitHub, to take one of my books to create a knowledge management system, like a nice chat to learn generative AI. I'm happy to do that. I don't need you to buy my book. I just want you to read it. So, and let's see whether we can do something. Okay. Thanks, everybody, and stay safe. I'll see you next week. Okay. I'm going to stop the live stream first. Stop the live stream.
Thank you, Sudha.
Thank you.